Hi guys. We're continuing with our theme of factoring. We have two more ways of factoring to learn, and I have them both written on the screen right now. We're only going to do one today. We're just going to do the difference of squares, but we have to do them both in the same section of your factoring book. And so that's why I wrote them both on the screen for you. And we're working in our last section of the factoring book, which happens to be like the second section, because I was trying to get the numbers in order over here. So we have GCF can be done for any problem. What we're learning today can be done for a binomial, something with two terms. The previous two were 3 terms, and then on Monday we learned about 4 terms. So if you're following along with your factoring book, both of these that we're learning or that are on the screen right now are going in the same section right here. So make sure to write them both on there, difference of squares, and then sum or difference of cubes. And today we're going to really focus on difference of squares. So this is the one we'll learn today. And then tomorrow, our last type of factoring will be sum or difference of cubes. And then basically for your book, what we're going to do is we'll do the difference of squares on the top, and we'll do the sum or difference of cubes on the bottom. So just everything for today's notes, just only write on the top piece of paper. So save the bottom piece of paper for tomorrow's notes, which is our last new type of factoring. If you're writing on lined paper, you only need to write down difference of squares because that's the only one that we're going to be covering today. So let's get started. Let's do this. So difference of squares is exactly what the name says. So difference in math means subtracting. So you're looking for something with a minus sign. And then squares is just, numbers that have a square root, things that are perfect squares. So in this basic example, right, it's an a squared and a b squared. In a difference of squares, it's going to be a binomial, only 2 terms. So for the past couple days, we've been doing things with 3 terms. Today, it's just 2 terms, so different size of problem. If you determine that something is a difference of squares, it has a subtraction sign and 2 numbers that you know the square root of, then you can factor it. It's super fast. It's something you just want to memorize. And basically what you're going to do is you're going to take the square root of the first number and you're going to put that at the beginning of 2 parentheses. So just like when we did Xbox, you're going to get 2 parentheses for your final answer. And then you'll take the square root of the second number and put it at the end of each parentheses. And then you need to make one parentheses have an adding sign and you need to make the other one have a subtracting sign. And that's it. So square root each number, one with a plus, one with a minus. Let's take a look at an example with numbers. So 49 minus y squared. So we check, does it have a minus sign? Yes. Can I square root both the numbers? Yes, I know the square root of 49, it's 7. I know the square root of y squared, it's y. And so this is a difference of squares. So again, here's the process. If you want to write it down, we're going to square root each number. And we're going to write 2 parentheses, one with a plus sign in between and one with the minus sign. You do have to make sure that you're keeping the order the same. So since the problem started with a 49, I am going to start my parentheses with a 7. So I get 7 plus y and 7 minus y in no particular order. So it doesn't matter which one is first and which one is second. You can put the plus sign first or the minus sign first. You just need to have one of each. That's pretty much it for difference of squares. So we're going to spend the rest of this video doing these trying your owns. Some of these are difference of squares. Some of them are not. Some of them get a little tricky. If you would like to pause the video and try them on your own, you can. Again, all of these are being written on the top paper in your factoring book. This bottom page should be completely blank. If you don't feel confident enough yet to try them on your own, I'm just going to go through and explain them right now. So if you want to try them, pause. If not, well, let's talk about them. So on the first one, again, it's 2 terms and there's a subtraction sign. That's good. And I know the square root of 4, it's 2. And I know the square root of a squared, it's a. And I know the square root of z squared, it's z. So I should be able to do this problem. I am going to keep the 2 and the a right next to each other, like the 4 and the a squared were. So my final answer is 2a plus z and 2a minus z. In no particular order. You also could have done 2a minus z and 2a plus z. On the next one, we don't have squares, but you know what, as long as the exponent is an even number, you can take the square root. All you have to do is divide it by 2. So anytime you see an exponent with an even power, just take it and divide by 2, and that's how you take the square root. So u to the 4th, the square root would be u squared, because 4 divided by 2 is 2. And then 4v squared, the square root is 2v, 1 with a plus and 1 with a minus. And in this one, I even switched the order. I put the minus first and the plus second because it doesn't matter. That's the final answer for number 2. Number 3, I've got a minus sign. The square root of 9 is 3. The square root of t squared is t. And then this is one that always trips people up. The square root of 1 is 1. 1 does have a square root. And so this is my final answer, 3t plus 1 and 3t minus 1. Now, the next one does not look like a difference of squares. It has a minus sign, but I do not know the square root of 18, and I do not know the square root of 2. However, we learned earlier this week that you can look for a GCF on any problem. So the first thing we want to do on number 4 is actually factor out a GCF, which would be the number 2. And then after you factor out the 2, then you can do a difference of squares. And so here's my final answer. Let me get you, this one has 2 steps, because first you should have factored out the 2. And after you factor out the 2, it's going to turn into a 9 minus y squared. So that's my first step. And then my second step is taking the 9 minus y squared and doing a difference of squares with that. So make sure, sometimes you do have to have 2 steps on these problems. You need, your GCF first and then your difference of squares. So just be really careful about that and don't try to skip steps. All right, the next one is kind of weird because it's got like a subtraction problem within the subtraction problem. But this is a difference of squares. So we can square root of 36, it's 6. And then if you square root this entire parentheses, the square root and the square just cancel, and you'll just be left with the x minus 5. So this one does count as a difference of squares. We would do it once as 6 plus the x minus 5, and then we would do it once as 6 minus the x minus 5. And then you do want to do a little simplifying within each of the parentheses. So in the first parentheses, I can combine my 6 and my negative 5. In the second parentheses, I will need to distribute my negative sign before combining like terms. And so my final answer on number 5 is 1 plus x and 11 minus x. And that was after I combined like terms. Number 6 gets a little bit weird as well. So it is a difference of squares. We talked earlier, when you square root a even exponent, you just divide it by 2. So we would get y squared, and then the square root of 81 is 9. So this is what we write down. However, that is not a final answer. We can actually keep factoring. So the directions in this chapter are going to be to factor completely, which means that we want to keep going on this problem. So after we've factored it once, we want to look inside the parentheses, and we want to notice that this parentheses right here is a difference of squares. It has a minus sign, and I know the square root of y squared, and I know the square root of 9. Now the other parentheses is not a difference of squares because it has a plus sign in it. And so I'm not going to factor that, but it is still going to be part of the answer. So I'm going to take my second parentheses, and I'm going to split it into a y plus 3. And a y minus 3. And then my first parentheses stays the same and stays part of the answer. Okay, so again, this one had 2 steps. Step 1 was difference of squares, and then step 2 was do the difference of squares again. All right, on that last one's a trick question. That last one is not a difference of squares because it doesn't have a minus sign. So that last one, we say it is prime. If it can't be factored, we call it prime. Okay, so on that last problem, go ahead and just write the word prime as your final answer. This concludes today's notes about factoring with the difference of squares. We have one more type of factoring, and we will learn that tomorrow.